All right, today we're diving into one of the weirdest, but also one of the most important ideas in all of physics. We're talking about quantum tunneling. You could almost call it the universe's very own ghost in the machine. So let me ask you a question that sounds like it's totally sci-fi. Is it possible for you to just walk through a solid wall? I mean, everything you've ever experienced, all the physics you learned in school would scream, no way, absolutely not. But when we get down to the quantum level, the strange and wonderful world of tiny particles, the answer is, well, it's not zero. And that's where things get really interesting. And this right here is the heart of the paradox. Look, in our world, the classical world, it's simple. You throw a tennis ball against a brick wall. If you don't throw it hard enough, it's just going to bounce back. Every single time, 100%. But in the quantum world, the world of atoms and electrons, a particle can come up to a barrier without enough energy to get over it. And sometimes it just kind of shows up on the other side. So what's going on? How is that even possible? Okay, to really get this, you gotta be willing to throw out the old rule book. Just for a minute, the rules that govern our everyday lives just don't apply here. See, quantum mechanics isn't built on concrete certainties. It's all about probabilities and chances. So, the key concept here is something called the wave function. And to get it, you have to stop picturing a particle like a tiny, solid marble with one exact location. It's not like that at all. Instead, think of it more like a cloud of possibility. This wave function is just a way of mapping out the probability of finding that particle anywhere in that cloud. Yeah, and this is the really mind-bending part. The particle isn't actually in any one spot until we go looking for it, until we measure it. Before that, it's just this wave of probability spread out all over the place. It's got a chance of being here, chance of being over there. It's everywhere and nowhere at once. And that waviness, that's the secret sauce that makes tunneling possible. So, okay, we've got this weird probability wave. How does that let a particle do the impossible and cross a solid barrier? Well, in physics, that wall is called a potential barrier. It's just a fancy term for any obstacle that needs energy to get past. The perfect analogy is a big hill. If you want to roll a ball to the other side, you have to give it enough of a push to get it all the way to the top. If you don't, it just rolls right back down to you, right? It's never going to magically pop up on the other side. But here's where the quantum weirdness kicks in. Remember that probability wave? When it hits the barrier, it doesn't just bounce off. A part of the wave actually leaks into the barrier. Now, it starts to fade away inside. It gets weaker and weaker. But, and this is the amazing part, if the wall is thin enough, the wave doesn't fade to zero. A little bit of it makes it all the way through and pops out the other side. That means there's a real non-zero chance that if you go to measure the particle, you'll find it on the other side of the wall. It is literally tunneled through. And really, it all comes down to one thing: the thickness of that barrier. The probability of this happening is unbelievably sensitive to it. I mean, if you make that wall just a little bit thinner, the chances of tunneling go through the roof, exponentially. But make it just a little bit thicker, and the chances drop to practically zero. It's a real knife-edge effect. Okay, I know what you might be thinking. This is some weird theoretical physics thing that doesn't matter, right? Wrong! This ghost in the machine isn't just a curiosity. It's the engine driving some of the tech you probably use every single day. I mean, just take a look. You got a fast computer with an SSD. The flash memory inside works because of tunneling. Those super fast electronics and modern devices? Tunneling. How about those mind-blowing microscopes that let us literally see individual atoms? Yep, you guessed it. They're called scanning tunneling microscopes for a reason. And the building blocks of quantum computers? They absolutely depend on this. I mean, seriously, let that sink in for a second. In the phone or computer you're using right now, there are billions upon billions of electrons. And they are constantly, deliberately, tunneling through these tiny, tiny barriers thousands of times a second. Why? To store the ones and zeros of your data. It's happening right now in the palm of your hand. That's not science fiction, that's just how your phone works. But this isn't just about our gadgets. The impact of quantum tunneling is so much bigger than that. It's not something we invented, it's something we discovered. It's woven into the very fabric of the universe. You could even say it's one of the universe's secret engines. Think about this. The nuclear fusion that makes our sun burn, that powers every star you see at night, it wouldn't happen without tunneling. Or what about radioactive decay, the process that lets us date ancient artifacts? That's also tunneling. It even shows up in biology, playing a role in how some enzymes work inside living things. It's everywhere. The story of the sun is just incredible. You've got all these protons in its core, right? They're all positively charged, so they should be pushing each other apart like crazy. The sun is hot, but it's not actually hot enough for them to have enough energy to just smash into each other and fuse. Based on classical physics, they shouldn't fuse, but they do. Why? Because they tunnel right through that repulsive energy barrier. Let me say that again. Without quantum tunneling, the sun would not shine. It's that fundamental.
So you see, this isn't some weird fluke. This bizarre quantum jump is happening all around us. From the fiery core of a star, all the way down to the silicon chip in your hand, quantum tunneling is one of the basic processes that makes our universe tick.
And all this leaves you with a pretty deep thought, doesn't it? Our solid, predictable, everyday world is built on top of this foundation of pure chance and probability. It really makes you wonder if something that seems impossible, like walking through walls, is actually happening all the time on a small scale. What other secrets is reality hiding from us? What else might be possible?